Hello, and welcome to Always Be Better with Mel Wyndham. Today, I'm going to introduce you to the Drake equation. This will require us to venture out into space. I know, sound exciting? For decades, scientists have been listening to the cosmos, trying to find signs of life, only to find none. Back in 1950, a scientist by the name of Enrico Fermi asked the question, where is everybody? And then Fermi's paradox was born. And seeing how quickly life had come to existence on our planet, it seems reasonable to believe that there are many planets throughout our galaxy capable of supporting life, able to send intelligent signals. You may have heard about the Arecibo radio telescope that collapsed a couple of months ago. It was strong enough to pick up radio signals from a big chunk of the Milky Way, and yet none of the signals show any sign of intelligence, just pulsating stars and other naturally occurring signals. So, where is everyone? There's one theory that may explain the lack of response, but you're probably not going to like it. Enter the Drake equation. Let's say that we would like to find other intelligent life in our Milky Way galaxy. First, we may try to estimate how many civilizations exist that are able to send intelligent radio signals. The Drake equation is a thought experiment to help guide our celestial listening. Should we expect to find many civilizations, or should we prepare to find few? All we have to do is multiply 7 numbers together and we get big N, which is the estimated number of advanced civilizations. What do all these letters mean? Let's dig in. The first term is N star. It represents the number of stars in the Milky Way galaxy. If every single star has an advanced civilization, that would give us 400 billion neighbors. Sounds a little high? Well, let's keep going. F sub p represents the fraction of stars that have planets. Our solar system benefits from being near the edge of the galaxy, but stars near the middle may not be so lucky, as volatile environments may destroy or cause planets not to form. So let's say this fraction is 1/4. This would bring us down to 100 billion candidates. N sub e represents the average number of planets in each planetary system capable of supporting life. For this, seeing how we may be able to terraform a couple of planets in our system, we can estimate 2 habitable planets on average. Now we're up to 200 billion candidates. F sub little l is the fraction of habitable planets that actually develop life, perhaps under the right circumstance. Life appears on its own, or perhaps there's a random element involved. For now, we'll say this fraction is 1/2, bringing us back down to 100 billion candidates. F sub I is the fraction of life-bearing planets that produce intelligent life forms. We'll assign a fraction of 1/10 to be on the pessimistic side. We're now down to 10 billion intelligent candidates. F sub c is the fraction of intelligent civilizations that learn how to create radio telescopes that can send strong signals that can be picked up light years away. We have only just now gotten to this stage in the last 100 years. Some intelligent civilizations could stay stuck in the Middle Ages and never figure out these higher technological advancements. So to be a little pessimistic, let's go with 1/10 again. But we still end up having 1 billion intelligent candidates capable of sending strong radio messages. But wait, There is one filter left, F sub big L. This would be the fraction of radio-capable civilizations that survive long enough to start up a conversation. The problem with advanced technology is that it also provides us with the means to wipe ourselves out in the wink of an eye. There are so many ways our civilization could die. We could die from mismanagement of the planet, or a resourceful terrorist in 100 years or so could build a bomb strong enough to ignite and consume our atmosphere. Or some other natural disaster such as a meteor strike or a rogue black hole could end us. Here, my friend Carl Sagan once provided a very pessimistic estimate of 1 over 100 million, which brings us down to a measly 10 advanced civilizations that survive. So yes, we've gotten this far, all the way up to F sub C, but this last filter is a big one. We've only been broadcasting for a few decades, a really small chunk of our whole Earth's history. And as I will explain eventually, we've reached a very important turning point starting in the late 80s. Something that has been both good and bad, but more recently, it's gotten to be very bad. And I sincerely believe that on our current path, we're not going to make it. In 1974, the Arecibo radio telescope sent a strong message to hopefully catch some aliens' attention. But by the time an alien picks up our message and comes to visit us, they'd be likely to find us already dead. Could this be the answer to the Fermi paradox? Do all advanced civilizations end up destroying themselves with their own technology? Will this be our future as well? I do see a path, as small as it is, to get us all back on track and turn recent advances into a very good thing and dramatically increase our chances of survival. Ultimately, this is the one main goal of this video series, to help us grab this opportunity and take the human race into the next level. It's an ambitious goal, but more than achievable. It really is about saving the world, and you, yes, you, have the power to help, as I will explain in later videos. While we work together to become better people, we will also simultaneously learn how to save the world. Eventually you'll come to understand, but I wanted to provide this very important introduction to help you realize what's at stake and what the ultimate goal is. We have a long way to go, but I believe we can get there. And we'll have lots of fun along the way. We can do this. Thanks for watching, and remember, we can always be better.